well, we've finished another unit. Unit 2, bodied. As my kids in Math for Life last year would say. Had no idea what that meant. What a wonderful education I got from them. By the way, this video is brought to you by the people that don't pay me any money. Brugger's Coffee. It's delicious coffee. It's just not very lucrative. So, I'm enjoying my coffee. Still haven't gotten my endorsement checks yet. Probably won't. At least they keep me awake. Well, I'm doing math. Now, this one's going to be a long one, kids, so we might as well get started. This is review. If you have not done the assignment yet, coming here, major waste of your time, because all you're going to do is copy everything I write down. Not the smartest thing to do in the world, okay? So you need to understand what's going on. You need to know what's going on in the world. So anyway, here we go. I am going to grab my pen in just a second and get started. Hopefully my pen is working properly. And we better get going because probably my computer's going to die halfway through. Well, like just now. Mr. Key. Sorry, I got a burp. Ooh, that wasn't good. Okay, so let's say this is the function right here. Let's see if this makes any sense. This point right here is the point 2, 4. Over 2, up 4. Hence the right 2, minus 2, and the up 4. It also has a dilation of 3, so it's going up rather steeply. It says determine the domain of the x values. So that is the lowest x value here going to the right. So that would be 2 to infinity. Determine the range. Well, that would be the lowest y value going up. That would be 4 to infinity. It says for what values of x does g of x equal 10? Well, here's 10. And it equals 10 when x is equal to 6. So the answer to this question is, in fact, 6. And the next question says, graph h of x, which is equal to, well, if I'm going to do that, I better erase all this crap I put on here because I'm going to graph a line. Let's graph it in red. H of x plus 2. So it's got a slope of 1 and a y-intercept of 2. Slope of 1 means we're going to go up 2 and over 2. Up 2 and over 2. Up 2 and over 2. Up 2 and over 2, up 2 and over 2, up 2 and over 2, up 2 and over 2. Not the greatest drawing in the world. Sorry about that. For what values of x is g of x greater than h of x? Let's see. This is g of x. And this is h of x. I think if I was to ask you this question, I would ask you, well, here it is. Here's where they hit. They're going to hit somewhere right around here. It's not exactly there. Let's say it is there for all intents and purposes. It's not the greatest grade. Hold on. Seems like I'm off here. Up 2, over 2, up 2, over 2, up 2. I guess it's drawn right. It just doesn't look right for some reason. At any rate, I think I meant to put minus 2. I wonder if I meant to put minus 2 on that thing. Because if I do minus 2, that's actually better. That's actually a better function. So when is g of x greater than h of x? Whatever. Let's go with what's there, though. When is g of x, h of x? G of x is greater than h of x. G of x is greater than h of x from 2, not including 2, all the way over. And let's say, for all intents and purposes, they hit each other around 12. So 2 to 12, it's greater than. It's not quite right. I don't like that question. I'm going to probably have to fix that one before we graph it. So if I changed it, I apologize. All right, we're going to solve. Isolate the weird thing. X plus 9 equals 20. You square both sides, and you get x plus 9 equals 400. So x equals 391. Wow, that was kind of a crazy question. Let's see if it makes sense. You're going to check your answer. You always should check your answer. You're going to do 391 plus 9 minus 8. Does that equal 12? This is the square root of 400 minus 8. Does that equal 12? And this is 20 minus 8, and that definitely equals 12. Check. We're going to simplify this thing, so we're going to rewrite it. X squared x times y. The square root of x squared is x, so my final answer is x square roots of x, y. We're going to simplify this one. Now we're looking for perfect cubes. Remember, our first perfect cube is 1. Our second perfect cube is 8. So this is 8 times 3. Remember, this is a cube root. A to the 6, we're looking for multiples of 3 since it's a cube root times a. And since b to the 9th, since 9 is a multiple of 3, we'll just leave that. Cube root of 8 is 2. The cube root of a to the 6 is a squared. The cube root of b to the 9th is b cubed. Cube roots of 3a. Done. This is a square root, so we're going to look for a perfect square that goes into 1 or 162, and hopefully by now you know 81 times 2. For these, we're going to look for even exponents. Well, 5 is not, so we're going to make it even by going x for x. And y to the 4th is even, so we're okay with that. Switch colors. Oops, forgot to switch colors. Square root of 81 is 9. Square root of x squared, x to the 4th is x squared. Square root of y to the 4th is y squared. Square roots of 2x. Done with page 1. I think we got like 8 pages to go. This is a long one. What is the difference when this is subtracted from this? Now, subtracted from is tricky. It's backwards. So this is 6 minus 5i minus negative 1 plus 3i. And if you remember, we talked about in class what's the common mistake made here, kiddies. If you understand the common mistakes, oftentimes you won't make them. And of course, our common mistake is not distributing the negative. So if we distribute that negative there, we get 6 minus 5i minus makes a plus 1 minus 3i. And again, subtracted from, we're doing backwards. So, and if we want it in a plus bi form, always give it in, oh, it says it right here. Forgot about that. So let's do the real stuff first. 6 and 1 make 7. Negative 5 and negative 3 make negative 8i. And don't forget, that could be checked using your calculator. If f of x equals that, sketch the graph of the transformation of f of x plus 4. What are the domain and range of the transformed function? Well, you know what I'm going to do first? I'm first going to graph what I was given, then I'm going to erase it. So this is x plus 2. The only shift is we're going to move to the left 2 units. Now, because this is a 1 and it's positive, we're going up 1 and over 1. And then over 4 and up 2. And then over 9 and up 3. So this is the original square root function. Oops, and it should go like, it should be going up like that. Okay. Then it says you're going to take this thing and you're going to take the whole thing and add 4 to it. What that means is we're just going up 4 units. So 1, 2, 3, 4. Up 4 units. So this here is f of x plus 4. Now, domain and range of the transformed idea. So the domain didn't change. It's still 2 to infinity. But the range, since we moved up, the range, the minimum value for the range is 4. And it also goes to positive infinity because it starts here at 4 and goes forever and ever up. Moving on up. Find the average rate of change. Now, if you remember correctly, that's going to be g of x2 minus g of x1 all over x2 minus x1. So this is, now over here, I'm going to figure out what g of x2 is. So what's g of 40? is equal to negative 1/2 the square root of 40 minus 4. Well, this is just the square root of 36. And the square root of 36 is just 6. So this whole thing just becomes negative 3. Now I'm going to do 20. G of 20 is equal to negative 1/2 the square root of 20 minus 4, which is 16. And the square root of 16 is 4. And negative half of 4 is negative. So we're going negative 3 minus negative 2. All over 40 minus 20. Not minus, just minus 20. So in the numerator, this becomes a plus. Be careful with your negatives. Always substitute in using parentheses, please. Maybe parentheses, please, is what I'm going to say from. So negative 3 plus 2 is negative 1 all over 20, and there is your average rate of change. We want to find the inverse function. We want to find the inverse function right here. So what we're going to do is we're going to write this as y equals square root of x plus 5. We're going to switch the x and the y, so we get x equals the square root of y plus 5. And now all we have to do is solve for y. Well, in order to get rid of a radical, by now you should remember that we have to square both sides. So this gives me x squared is equal to y plus 5, or y is equal to x squared plus minus 5, or m inverse of x is equal to x squared minus 5. Now this is not entirely correct. I'm going to address it in class a little bit, but quite honestly, it's a little bit more probably advanced for you guys, but let's just see about this. Let's look to see what this thing is. Oh, I forgot the minus 3. So let me erase all of this, because I do want to talk about one thing, and I forgot to talk about this at the beginning. And that's my fault. The domain of this is negative 5. Why did I just write that? Negative 5 to infinity. And the range is negative 3 to infinity. Well, when we take the inverse, these have to switch. So let me rewrite. You already got this first step. This is going to be x equals the square root of y minus or plus 5 minus 3. Now, I have to isolate the weird thing, so this is the part I skipped. X plus 3. I made this problem like 10 times easier than it was. X plus 3 equals the square root of y plus 5. Now you square both sides, and I get x squared plus 6x plus 9. That's writing this twice and double distributing, but I'm doing it in my head, is equal to y plus 5. Or x squared plus 6x plus 4 is equal to y. So my inverse function is x is x squared plus 6x plus 4. But, and this is the hard part, this is going to be my new domain. Remember, when you do inverse, domain and range switch. So my new domain is going to be from negative 3 to infinity. I'm not sure I want you to do that one. We'll see about that. Maybe I'll put that on as a bonus question. Squared means write it twice. It does not mean square those things, dummy. I'm going to get a kid who goes, well, it's 9 minus 49i squared. And I'm going to say, no, you're kind of not very smart. You just made the dumb mistake that everybody else makes. Write it twice and distribute. 3 times 3 is 9. 3 times negative 7 is negative 21i. And the other one, now we're going to distribute this way. Negative 21i. And then negative 7i times negative 7i is positive 49i. I squared because it's negative times negative. Now, you have to remember, oh yeah, Mr. Krause, I squared is really negative 1. So this whole thing here is really just a negative 49. Well, negative 49 and positive 9 make negative 40 minus 42i. Now, just as a reminder, this can be checked using your calculator as well. Come over here, you put some parentheses, you go 3 minus 7i. I will expect to see work, not that you're just a monkey and use your calculator and go, oh, look, there it is. Negative 40 minus 42i. Negative 40 minus 42i. I will expect that you do your own work here for that. Where'd we go? All right, here we go. Let's go down. Isolate the weird thing. So we get square root of x minus 8 equals 7. X minus 8 equals 49 when you square both sides. Or x is equal to 57. Done. I'm not going to check it. It's the right answer. I want to do this. I really want to have some coffee. So this is a cube root function that moved 2 units to the right, but it did not move up or down. It also does not have a steeper or a dilation. So we're going to go to the right one and up 1. We're going to go to the left 1 and down 1. Now, if I looked on my table of values, if I popped over to my table of values, I'd say x and y. Somewhere on there, it would say 1 is negative 1. 2 is 0. 3 is positive 1. Now, the one before that, I'm not sure about that one. Let's go this one. I need to get out to 8. So at 10, it would tell me my answer is 2. So that's 8 above. So at negative 6, if I looked on my table, on my calculator, at negative 6 it would tell me it was negative 2. So there is the cube root function they asked us to graph. But they asked us to graph it only from negative 6 to 10. So I really should not have arrows on there. In fact, I have to delete this whole line because I really shouldn't have arrows on there. I should just go like this and stop. All right, let's see. I to the 0. Anything to the 0 power. Well, remember, when we multiply, we add the exponents. So this becomes I to the 1, 3, 6. Now, if you remember your I circle, I to the 1, I squared, I cubed, I to the 4th. And remember, this is just I. That's easy. This one is I squared, which is negative 1. That's the one, that's the big one you have to remember. And then opposite is positive 1, or opposite is negative I. So count to 6. 1, 2, 3, 4, 5, 6. There it is. The answer is negative 1. I could rewrite it as I to the 4th times I squared. And this I to the 4th is just 1. I squared is negative 1. That's why it's negative 1 as well. How do these functions compare? Okay, so how does g of x, which is just the cube root of x, compare to this? Well, g of x moves right 2 and up 1. G of x has a dilation higher rate of change than f of x does. And it's got a slope of 3, or it's got a rate of change that's 3 times as high. All right, we're going to simplify completely. We're moving. I don't know where my mouse pointer is, but we're moving. It's a cube root, so I need to find a perfect cube that goes into 64. Well, luckily for me, 64 is a perfect cube. For these, I want to find multiples of 3. So x cubed x, y cubed. And since we're simplifying, we'll grab a different color. The cube root of 64 is 4. The cube root of x squared is x. The cube root of y squared is y. So my final answer is 4xy cube roots of x. Solve and get the weird thing alone. Square it. Square it. So I get 5x minus 6 is equal to x squared. Since my x squared is positive, we're going to move everything over there. So we get 0 is equal to x squared minus 5x plus 6. So I need two numbers that are going to add to 5x and multiply to positive 6. So that means they both have to be negative. And that's going to be 3 and 2. So my two answers are x equals 3 and x equals 2. You must check these answers. I'm going to guess one of these probably doesn't work. I'm going to guess on test day one of them is probably not going to work. So let's check. 5 times 3 minus 6. Does that equal 3? Well, that's 15 minus 6, which is 9. Square root of 9 is, in fact, 3. So that one works. Now we're going to do the other one. 2. 5 times 2 minus 6 equals 2. 5, that's 10 minus 6, which is equal to the square root of 4, and that equals 2. So they both work, so we're good. Both of them. So, well, I can do one of two things. I can just plug this in, put in my calculator to 1/2, or I can remember that a 1/2 is really the same as a square root. So this is just 4, and my answer is 28. So you can either use your calculator just by going 7 parentheses 16 parentheses raised to the fractional 1/2. But 1/2 is just the square root. And that was that easy. Moving on up or down. The product means multiplying. So we're going to have to double distribute. 1 times 1 is 1. 1 times negative 2i is 2i. I times 1 is I plus I. I times negative 2i is negative 2i squared. And don't forget, I squared is really negative 1. So what you have to do is remember to do that. Well, negative 1 times negative 2 is really positive 2. So this whole thing is really a positive 2 here. And I put it together with this. I get 3 minus I. And this is in A plus BI form. Don't forget it. All righty. We got to graph this sucker. And I only want to graph it where x is less than 2. So what I'm going to do is I'm going to graph the whole thing. And then I'm going to erase the stuff I don't want. So let's see what I got here. Let me grab a different color. All right. All right. So y-intercept of 2. And it's negative. So negative 1. But I only want to graph when x is less than 2. So I think I want to stop right here at 2. I don't want to do any of that. I just want to graph this line. It goes forever and ever in that direction when it is less than 2. Now, the other thing I got to be careful of is it said less than 2. So at this point right here, son of a... See if I can get rid... Oops. Let's see if I can get rid of just my... dot. All right. So the problem with it is I can't have a dot there. I have to have an open circle because it says less than. Now we're going to talk about this thing. It's a square root function, so I got to find out where this point is. And it's not very steep, but it is going up. So we're going to go to the right 2 and up 3. So right 2 and up 3. And that's going to be a solid point because it says equal to. And we're going up by 1 and then going over 4 and up 2. So 1, 2, 3, 4, and up 2, and I draw that in. There it is. Given this function, find the average rate of change from 0 to 12. Okay, so from 0 to 12, f of 12 is the square root of 12 plus 4 minus 3. Well, this is really the square root of 16, and the square root of 16 is 4, so 4 minus 3 is 1. F of 0 is equal to square root of 0 plus 4 minus 3. Well, this is really the square root of 4, which is 2. 2 minus 3 is negative 1. So my average rate of change is equal to 1 minus negative 1 all over 12 minus 0. Sub it into that formula. This becomes a plus, so it's really 2 over 12, or 1/6. All right, here we go. So we got to double distribute here. Double distribute. So we're going to multiply this times this, and I get 12 square roots of 9 plus 8 square roots of 6 minus 18 square roots of 6 minus 12 square roots of 4. Now I'm going to do a little simplifying. Square root of 9 is 3, so this is really 36. And the square root of 4 is 2, so this is really minus 24. I'm going to put those two together, and then these two combine together as well. So those two combine to make 12, and the other two combine to make minus 12 square roots of 6. Michael graphed that equation on the calculator using the table. What is the average rate of change over the interval from -3 to -1? So we're going to use the table there. So that already gives us the function values. Remember, we're going to do the functions on top, or the y values on top. So average rate of change over that interval is going to be, at -1, it's 5.75 minus 4.25 all over -1 minus -3. Well, these make a plus, so it's really -1 plus 3, which is 2, and 5.75 minus 0.25 is 1.5. All right, so this really becomes 3/4. Put in your calculator, probably be 3/4. I guess I could live with this. I don't like decimals and fractions at the same time. All right, kids, we're going to write this in simplest form. Again, if I'm moving too fast, slow down. Boys and girls, if you hit the subscribe button, you make me happy. If you hit one of my links, that even makes me happier. So 2x. We're looking for perfect squares. I know it's 72. Do not pick 9 and 8. 36 times 2 is the biggest perfect square. And then we're going to write these as even exponents. X squared x, y to the 4th. Let me grab my other tool. Square root of 36 is 6. Square root of x squared is x. The square root of y squared is y, or y to the 4th is y squared. So I'm going to put all of this together, and I get -12 x squared, because I got an x on the outside and an x that I took out, y squared. Square roots of 2x. Now, in order to add radicals, we have to have the exact same radical. I do not have the exact same radical here, so I need to simplify. The square root of 80 can be written as 16 times 5, and the square root of 16 is 4. So this is really just 4 square roots of 5 plus 3. This is the square root of 9 times 5. What is the square root of 9? It's 3. So this becomes plus 27 square roots of 5. And lo and behold, I get 31 square roots of 5. Now, you would really like to know if you got that question right. You come over to your calculator, square root of 30 plus, so the square root of 30, 80, plus 3 square roots of, forgot what it was, kids, 45 is that obnoxious number. And we came up with 31 square roots of 5. So do 31 radical 5. And hopefully we get the right number, which we did not. So I did something wrong. See how that didn't work? So I made a mistake. So we got to fix it. Now, I either made a mistake checking it or I made a mistake doing it. Here it is right here, right? 3 times 3 is 9, not 27. So do you see how I was able to make a check and do it, right? I know you won't make that mistake because, you know, nobody ever makes that mistake. 13 square roots of 5. Yeah, right. By the way, I did not do that on purpose, but it's a great teaching tool. So I come up here and I say, oh, wait, I didn't mean 31 square roots of 5. I meant 13 square roots of 5. It's like I'm dyslexic or something. 13 square roots of 5. And look at that, 29.06, that weird number. All right. There's the model at a speed of a tsunami can travel. We want to find S inverse of D. All right, so we just got to switch X and Y. So this is Y equals 356 square roots of D. Or D is equal to 356 square roots of Y. Isolate the weird thing, so you get D over 365 is equal to the square root of Y, and square both sides. So I get Y equals D squared over 133,225. 133,225. That's it, basically. I should write it as S inverse of D is equal to D squared over 133,225. Dumb question. All right, in order to add, we have to have the same radical. In this case, it looks like it's going to be radical 6. So I can rewrite it as 2 radical 6 times 4. Should have read the 4 first. Square root of 4 is 2. So I get 4 radical 6. And this is going to be 3 radical 16 times 6. Square root of 16 is 4. So I get plus 12 radical 6. And so that is just 16 radical 6. There she is. 27. We're getting close, kids. We're getting close. I think I only got like 75 problems on this problem test. All right, 27. We're going to graph the inverse on the same set of axes. So if you remember, the inverses are reflections over the line y equals x. So this point would come 1, 2.5, half, 1, 2 here. And this point would go just a little bit past 2 here. And there you go. Something like that. Simplify. Square means write it twice. So this is pi minus the square root of 3. All right, squared means write it twice. So pi times pi is pi squared. Makes you hungry. Wants some apple pie. And then we're going to get minus 3 minus the square root of 3 times pi. So the better way to write this, since you don't want to pretend or accidentally put the pi underneath, is pi radical 3 minus pi radical 3 plus the square root of 9, which is really just 3. So you get pi squared minus pi radical 3. Oh, excuse me, minus 2 pi radical 3. So it's pi squared minus 2 pi radical 3 plus 3. Simplify. We're looking for perfect cubes. The perfect cube that goes into 32 is 8. 8 times 4. X to the 6 is okay. Y to the fourth is not. I need it as a y cubed and just a plain old y. So the cube root of 8 is 2. The cube root of x to the 6th is x squared. And the cube root of y cubed is just a y. So my answer is 2 x squared y cube roots of 4y. Isolate the weird thing, so it's going to be square root of x plus 1 is equal to, well, 5 minus x. Now I got to double distribute because I want to get rid of that radical, so I have to square both sides. So this is just 5 minus x. So this is just, if I square this side, I just get x plus 1. This one I have to write twice and do some math on. So this is equal to 25 minus 10x minus 5 plus x squared. Everything, these two things are going to come over here. So I get x squared minus 11x plus 24 equals 0. Signs have to be the same. They both have to be negative. So x minus 3 and x minus 8, or x equals 3 and x equals 8. Let me check those real quick. The way I would check these is like this. I would go over here and I'd say 3 sto x. And then it was x plus the square root of x plus 1. 5. And we want it to be equal to 5. And our other answer was x equals, we wanted it to equal 5 because that's what we said right here. Our answer is 8, so we'll do 8 control var x. And we're going to type the same thing in. Enter. And then we're going to type that same thing in and see if this one works. And remember, we want it to be equal to 5. Oh, it doesn't equal 5. So apparently 8 is not a solution. So the only answer is 3 in this particular case. Find a of x given a inverse. Well, inverse, we just switch x and y. So call this y is equal to the cube root of x plus 27. So x is equal to the cube root of y plus 27. So this is, now you're going to cube both sides. So I get x cubed is equal to y plus 32. Bring the 32 over, so you get a of x is equal to x cubed plus 32. All right, I want to graph this one. So this one we're going to move to the left 4 and down 2. So left 4 and down 2. And it's coming down. 1. If you looked at your table of values, this is what you'd see. And the other one is just negative 3x minus 5. So negative 3x minus 5. Down 3 over 1. Oops. So that's this line. Now the problem is they don't really want to graph all that. I don't know why I just did that, because I'm getting tired. I don't know why I'm so tired. So although, I don't know why I did this. Although this graph looks like it moves over to the left 4 and down 2. And it's doing this. I only want a graph where x is greater than 0. So what I need is an open circle here. So now I need to know, I'm going to go over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 3. 1, 2, 3. So those are the 2 points I really got to get through, because I only want to go from 0 to above 0. Oh, shoot. So I'm going like that, skipping the first part. And then negative 3x minus 5 has a y-intercept of negative 5, which is right here. And it's closed circle, and it's going down 3 to the right 1. But we only want to go for x is less than 0, so we'll only go in this part right here. Whew, getting tired, kids, getting tired. How many problems I got left? This is 33, and we've got 38, 5 left, but 3 are hard. Which interval has a greater range? Average rate of change, 1 to 6 or 1 to 13? Well, 1 to 6, from 1 to 2, 3, 4, 5, 6. That's about this steep. 1 to 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. That's about that steep. So which one has a greater average rate of change? From 1 to 6. Now you really should show using the table or using your graph. So let me erase and let's get those points on there. So if you were doing it using the graph, this is 1. And 6 is 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13. So from 1 to 6, that's from here to here, we're going to go up 2 and over 6. From 1 to 13, we're going to go up 4 and over 1, 2, 3, 4. So it's going up 4 and over 13. Over 12. Oh, this is 1/3. And this is 1/3. Uh-oh. They have the same average rate of change? Can't be. Oh, no. Brain fart. This is what happens when you don't show your work. That's what happens when you don't show your work. I'll show my work now. So I'll get the right answer this time. So let's draw. So this would be 2 minus 0 all over 6 minus 1, which would be 2 over 5. This would be 4 minus 0 all over 13 minus 1, which is 4 over 12. So this is 1/3, and this is slightly bigger than 1/3. So this would have the higher rate of change. And it's steeper in that area. All right, sketch the inverse of this function. So again, inverses are a reflection over the line y equals x. So I'm going to pick some good points here. Pick this point. I'm going to pick that point, and I'm going to pick this point. And really, it's just switching the x and y's, right? So this is the point 0, 3, so we're going to pick 3, 0. This is the point 1, 2, 3, 4, negative 1, so negative 1, 4. And this is the point 9, negative 3, so negative 3, 9, which is way up here somewhere. And so this would be my inverse function. That's it. Now we're going to do a little bit of linear regression. We got 3, I think 35, 36, 3 linear regressions and 1 weird one. All right, so let's do this linear regression. So we need to bust out the calculator. 25, 50, 100. Looks like they're going up by doubling every time. So I'll go over the calculator. Go into calculator mode. Make sure you are not 1.1 and 1.2. You got all kinds of crap here. We got to get rid of that. I don't want to see that. So go back into spreadsheet mode. All right, so we're going to call this skid S. And speed. Well, let's call this length and speed. So 25, 50, 100, 200, 400, 800, 1600, 3200. I think it went like that. 23, 32, 23, 32, 46, 65, 46, 65, 92, 143, 92, 143, 225, 300. All right, now we're going to go into menu. And we're going to go 4, 1, and we're going to do, hit the wrong button, 1. Oh, menu, 4, 1, 9. We're doing power regression, length, skid mark, and there's my equation. So 3.853. 3.853 is A. A is 3.853, 85397. B is 0.54066, 0.54066. So it says round all nearest to thousands place, so 3 decimal places. So this is 0.54. Make sure I got this right. 4066. 66. So y equals a times x to the b, which is what they told us is the equation. They tell it right here. Y equals a times x to the b. And we want 1,000. So y is equal to 3.854 times x raised to the 0.541. How long will it take a ski? What's the speed of a vehicle if it takes 1,000 meters? So the 1,000 we're going to just plug in for x. So we're going to get y equals 3.854 1,000 times 0.541. Got to grab my calculator for that. 3.854 3.854 times 1,000 raised to the 0.541, and hit enter, and I get 161.733. So 161.7331. It said, oops, I forgot to tell you how to round, so let's round to the tens place. Round to the tens place is 16.7. Does that make sense? No, 161.7. Does that make sense? 1,000 right in here, 161. Kind of makes sense. All right. So the table below gives the mean distance x from the sun in astronomical units and the period y in Earth years of the 6 planets closest to the sun. Write the power regression model for this data. All right. So I do it again. No. Don't save. Let's go back in. X and Y. They called it X and Y. We might as well call it X and Y. 0.38, 0.72. 0.38, 0.72. 1, 1.52. 7.89, and 14.98. Now the reason it's 1, 1 for the Earth is because it's 1 Earth year. It's just, that's the basis of reference. 0.21, 0.61. 1, 1.67. 14.54 and 24.61. All right, we got them all in. Come back over here. You go into menu, number 4, number 1, and number 9. We're doing power regression. My X and my Y, and I click OK. And there it is. There's my equation. There's the equation. Y equals A times X to the B. So Y equals A times X to the B. I just got to figure out what A is. A is 0.89164. 0.89164. And B is 129.040. 129.040. Over. So my equation is going to be, and I'm going to use f of x. I just think it looks more grown up. So f of x is equal to A, which is 0.8. We're going to the thousands place, right? So 0.892 times x to the 129 point, I don't like 040. So I'm going to highlight over that 0429, 1.29. Oh, it's 1.29. 1.29. So we're going to round to the thousands place. We're going to decide about this. So it's 1.29040. And we're going to leave it as over. So it's 1.290. Ooh, almost screwed that up. 1.290. So now I want to know about 9.1 astronomical units. Well, remember, astronomical units are x. So we're going to plug this in for x. So I do 0.892 times 9 raised to the 1.290. Now 9 should be somewhere in between these two, would be my hope. So go to calculator. There you go. 0.892 times 9 raised to the 1.290. 1.29. I'll have to put the 0 in. 16.714. So 16.714. And yeah, it's in between, so that's kind of good. Rounded to the, well, I didn't tell you to round where this one is. So we're going to round to the nearest hundredths place. Now, yeah, hundredths place. So 16.71. 2 left. I want to name this equation. Oh, sugar, sugar, sugar. So let's see. This is an absolute value over here. The vertex moved 5 units to the left. So it's the absolute value of x plus 5. And it didn't move up at all. And let's see how steep it is. That's 3, 3. So it's moving up 2 over 2. So it's just no steepness or whatever. But I only go from where x is less than or equal to -3. Now this is the square root function where, oh look, it's going up 1.5. So this looks like it's 3 halves. X plus 3 plus 1. And this is for x greater than -3. Well, that was a tough one right there. All right, moving on. Last one. There's that weird formula. How long does it take for the pendulum to swing back and forth if the length is 2 feet? So length equals 2. Oh, so this is the time it takes. So this is time. So time is equal to 2 pi square roots of L over 32. So I just got to plug a 2 in, it looks like. So time is equal to 2 pi square roots of 2 over 32 instead of L. So I'm just going to do that on my calculator. 2 pi, so 2 pi times the square root of 2 over 32. 2 divided by 32. It'll fix what it looks like. 1.5707. 1.5707 is the time. And will it swing faster? I got a round here too. So let's round to the tens place. So let's round to the hundreds place. So t equals 1.57. Will it ring faster or slower if the length is increased to 5 feet? So now it's t equals 2 pi. So now it's 5 feet, 32. So I'm going to do the same exact math, except now instead of 2 feet, I'm going to make it 5 feet. And of course, this is going to be slightly larger, 2.48. So time equals 2.4836. So that's time equals 2.48. And obviously, it's longer the longer the pendulum. You know, if you think about it, back and forth. Will it swing faster or slower? How long does it take for the pendulum to swing back and forth if it's 2 feet? Well, it's going to swing a lot faster if it's 2 feet than slow feet. If it said how much faster? Will it swing fast? It's swinging faster. No, it's swinging slower. Slower. Swinging slower. It's taking longer. Solve for L. What are you guys crazy? Solve for L. Solve for L. So let's see. Got to isolate the weird thing. So S over 2 pi, because I got to divide both sides by 2 pi, is equal to radical L over 32. I'm going to square both sides. So I get S squared over 4 pi squared is equal to L over 32. Then I'm going to cross multiply. So I get L. No, I'm just going to multiply both sides by 32. Because that gets rid of this 32. And then 4 goes in here 8 times. So I get 8s squared over pi squared. That's equal to L. What is the length of a pendulum that swings back and forth in 2.5 seconds? So I'm just going to sub in 2.5 into this equation. So 8 times 2.5 squared all over pi squared. So 8 times 2.5 squared all over pi squared. And 5.066, and I should tell you to round. 5.06605. So 5.1 something. I don't know what the units are. Feet. All right, that's it. That's all she wrote, kids. If you can do that, you can do this test. I think I might add a couple things. So if I add a couple things, I'll throw another spot video on. I might add a couple more problems. But anyway, this may not be the end. Maybe I'll just do them in class and see how you do with them, okay? All right, kids, that's it. That's all she wrote. I think you can handle the test. Good luck. Hit the subscribe button, hit the like button, hit the links, hit the donate button, hit everything. If you want, just hit it all. Just click, 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 click. But make sure you understand what you're doing. All right, take care, kids. Bye.